Just one cup. Did you guys go anywhere for break? Where did you go, Allie?
Florida.
Florida? It shows. You got that bronze color. Anybody else go anywhere for break? Stefano, did you get to travel?
Michigan.
Michigan, that's right. You went north. So I went to, did I tell you where I was going before break?
Texas.
Texas, yeah. We go to Florida so much. After a while, they all start to look the same, the beach towns, right? So we just decided to go to San Antonio, which is a really cool city. I didn't realize it's the 7th largest city in the country. It's huge. But they have, downtown, they have what's called the Riverwalk, and it's really a cool little area. And it was warm, 75 to 85 the whole time, not a drop of rain. So just like you, I'm trying to get back into the flow of things. So we're beginning a new unit, and it's on the cardiovascular system. And one of the things that we will do is learn how to write a proper lab report. How many of you have done this before? Ever? Silence. What does this mean?
I want to say Talinka made us do one.
I thought she did. She teaches what, BG Chem, and I'm pretty sure they require at least one. Did she do it for BG Chem?
I can't remember.
I think she did most of it for us.
She did most of it for you. Okay, well, you're going to, I guess, relearn if you took BG Chem. If not, it'll be learn how to do it for the first time. I will not be doing most of it for you, but I will show you samples. I will, hold your hand through the process and teach you kind of how we do a formal lab report. It seems like a big deal, but I tell you what, if you go into the sciences in college at all, it becomes very easy. As long as you know the proper pattern to follow and the rules on how we write lab reports, it is really not hard. I thought, when I was a microbiology major, the first time I had to do a lab report, I was like, holy moly. And then I got to where I could crank them out like really easily. And they weren't hard, right? You will grow from the process if you end up going into a STEM field. So I have a handout for you to follow along, and it's all about how to write a science paper or a scientific paper. We'll look at a sample of a student who did a fantastic job. I grabbed her lab report to share with you. She today is a doctor, so she's done well. I'm not sure what kind of medicine she went into, but I've had lots of really good lab reports over the years. As we study the cardiovascular system, one of the things that you're going to do in lab is investigate blood pressure. So your lab report will actually be on our blood pressure lab. You'll learn how to use a sphygmomanometer, which is a fancy way of saying a blood pressure cuff monitor, right? You'll take people's blood pressure in class. And we'll ask the question, how does exercise affect a person's blood pressure? And you'll end up writing a lab report on this. So we've got a lot to do between now and then, but I wanted to introduce to you the idea of a lab report, take you through the steps. If you look over here at the roadmap, it's all about lab reports today. So I'll show you how to write a proper introduction to a lab report. There's a section called the materials and methods, so I'll take you through that as well. Another section called the results, and then the final called the discussion. Does this look kind of like what Talenko taught you? Yes? Jacob? All right, I can tell you're just back from spring break. And then I'll give you some time to go through a lab report today. I'll give you copies of a lab report. You cannot take photographs of the lab report, but you can read it and take notes, make like mental notes yourself of things to do and not do. So we'll go through all of this today. Now, the University of Findlay, one of the things they want all their students to be able to do that are taking these core science classes is to know how to write a proper science paper. So as I just went through in the roadmap, we have really 4 parts to a lab report. We have an introduction, and I'll go through each part and what you'll do in each part. We have what's called the materials and methods. We have the results, and we have the discussion. And it seems to me, from what I heard a few seconds ago, that this is not something you feel like you could just do right now, right? You would probably struggle with it. Like I said before, though, it is not as hard as it sounds. There's a basic formula that you follow, some basic guidelines, and if you use this handout, right, and you take a look at the sample I give you, you'll be able to do this pretty easily, I think. Like I said, in our investigation, we're going to look at how exercise impacts blood pressure, but at the same time, during that lab, we'll also collect data on heart rate and some other factors as well. And you're able to include more information in your lab report than just information about the key question. So that's kind of what your introduction is all about. It's a time for you to do some background research, to learn about the topic itself. You're going to want to state the intent of your investigation during your introduction. What is your hypothesis? Okay. Right now, if I ask you to think about blood pressure, right? How many of you have ever had your blood pressure taken? Can you give me an example of a blood pressure?
180? Is it 180 over 20?
Well, at least you know there are two numbers, right? So we have a systolic and a diastolic reading, and one is when the heart is, the ventricles are compressed under the compression stroke, right? And that sends our blood pressure up temporarily, and the other one is during that relaxation phase. So we have two numbers that tell us about our blood pressure, and we'll do it both by hand using a manual sphygmomanometer, the kind that the nurses use, and we'll collect a lot of data using electronic sphygmomanometers. In my opinion, if you know what you're doing, it's more accurate to use a do it by hand, where you're listening with a stethoscope, and I'll teach you how to do that. But when we're collecting a lot of data, it's kind of nice to have the automatic readings as well. So we'll do both. But yes, a typical, you might hear 120 over 80, and it's measured in millimeters of mercury. So that's something we'll get into when we get to the lab as well. So you'll want to state your hypothesis. If you think that exercise will have an impact on a person's blood pressure, how would it affect that? And then based on what you've researched, why? Right? So part of your introduction has to include your hypothesis, which is just a prediction of your results. So that means you kind of have to do that preliminary research first. You have to dig in a little bit. The next part of the lab report will be to do the materials and methods. This is going to be an explanation of how you performed the actual experiment, what procedures were followed. If you did calculations, you should include how you would have done those calculations. You want to avoid plagiarizing the lab manual. So even though you're going to have directions to follow, you want to make this kind of your own words, how you did the work. Also, we don't list the steps, we use complete sentences. It'll be a description of what we did, not just a list of the steps. Somebody reading your lab report should be able to repeat your experiment, ideally without talking to you, right? We know that scientists collaborate and they reach out and they work together, but if somebody reading your published work in Japan, right, wants to repeat the work, they should be able to see what you've done, do your experiment again to see what the results are. So that's kind of the detail that you want with the materials and methods section. Anybody have any questions on that? Now, the results show what the data revealed, but they do not interpret the data. You'll save that for the discussion. So you're going to create tables that show the class results that we collected. Now, we have a much smaller number of people taking anatomy now that we shifted the sequence of science courses around. Typically in the past, I had 40, 44, 45 students, and obviously we have one section now, and what are we at? 16, 17. So we're going to have less data than normal, but I do have access to data from previous years that if you wanted to look at, you could. So we're going to create tables and graphs that show the results, but this section doesn't interpret the results. Also, each table or graph needs to be properly titled and should have a brief description of what is shown in the data, okay, the table or the graph. So examples, like table 1 might be titled pre and post exercise heart rate. Okay. I know it's about blood pressure, but we often collect information about heart rate as well. Table 2 might say blood pressure versus body position. So one of the things you'll do is you'll collect blood pressure data after your classmates are lying in the supine position on a lab table. Okay, you'll do it post-exercise. You'll do it in several different scenarios. Well, when you put that data together in a table, we want to let the reader know that they're looking at blood pressure that was collected right after or during a person laying in the supine position. So beneath each table, you should describe the contents of the table using a couple of complete sentences, but not interpret it. Again, you want to avoid interpreting data. So you're not going to say why you think the results are the way they are yet. You're going to save that for the discussion. Just simply state what the data reveals. I'll give you an example there in just a moment. But another thing I want to point out, that graphs are labeled as figures. Maybe put a little star next to that in your handout. A table is going to be a list of data typically, right? Numbers and columns. A graph is going to be labeled as a figure. So here's an example of a description of what the results showed without interpretation. Okay? And this is, again, this is made up. Don't copy this. It's just an example, a model for you to follow. It says, as shown in table 2, blood pressure was consistently highest in the standing position right after the subject changed from the supine position. It was noted that in most cases, this rise in blood pressure decreased somewhat after the subjects had been standing for a period of 2 minutes. This was true for most subjects. However, as can be seen from subject number 32 and number 12, blood pressure remained elevated even after the 2-minute time interval. So what that description showed was what the majority of the data looked like, and also it shared some outliers, some individuals that didn't seem to fit with the rest of the data. But nothing was done to explain why that might have been the case. That's what you get to do during the discussion. So you want to begin by stating whether or not your hypothesis was supported by your data. Okay? Did the evidence that we collected support your initial hypothesis or not? You should indicate how the results do or don't support your hypothesis. Point out like why you made that decision. For example, you might say, as table 3 indicates, the hypothesis that exercise would lead to elevated heart rate was supported by the data that was collected. This is also an opportunity for you to explain why you think the results are what they are. You should include the research you performed before executing the experiment. You could circle back to that. Also, during the discussion sections where you want to include any conversation or discussion of sources of error and how the procedure could have been improved. So if you reflect on the experiment and you think, wow, you know, it probably would have been better to make sure everybody exercised for the exact same period of time. Like maybe one group decided they were going to do, 5 minutes of exercise, and they were doing stairs, and another group did jumping jacks. Those kinds of issues might give us different results, right? We want everybody in our data set to be doing the same kind of exercise before we measure blood pressure and heart rate. And if that didn't happen, then you could talk about that. Now, the fact that I pointed that out as an issue hopefully means you avoid doing that, right? That we keep our experimental groups the same. You're going to be required to have a references page. In science, we use the APA format. I think in English class, you probably use MLA, correct? Neither are that difficult. You can easily look up online on a website the differences in formats. And we get to that point of class 2, I will show you some samples. But in my day and age, it was, you had to kind of like get to dig around and learn in class. And I think most of you have done citations for English classes, but since you haven't written a lot of papers in science, You probably haven't done the MLA format, but that's what we use in the world of science. What I've done for you is I've kind of curated a list of common mistakes that students make when they write lab reports. Most of these things are common sense, but a few of them will shine a spotlight on the other ways that we write, like what voice we write in, what tense we write in, and that's something to look at as well. So I'll start with that. When you write a lab report, you want to use the third person and passive voice, and I'll show you what that means in just a moment. Well, actually, I'll do it right now. So you're not going to write, I recorded the number of beats per minute, okay? Instead, you would say the number of beats per minute were recorded. Not I, not we. Okay. When you look at the sample that I provide you in a little bit, you'll see the way the student wrote it, avoiding to say I did this or we did this. Also, forgetting to put titles on tables or graphs. Interpreting the data in the results section. You want to avoid doing that. Again, during the results section, you're simply stating what was found. You're showing it in graph form or table form. You're writing a brief few statements about the data, like I showed you that example earlier, but you're not going to interpret it until you get to the discussion. Don't use the terms that we proved our hypothesis was correct. You're not really supposed to set out to prove anything, right? You want to be an unbiased collector of data. You want to say the data supports the hypothesis or the data doesn't support the hypothesis. So don't say, if you want to lose points on your lab report, write, I proved my hypothesis was right. Because that tells me you were looking to be right all along, which then means you might not have looked at the data in an unbiased way. Okay? So we don't use the word prove, proved, proven, etc. Forgetting to do references or using too few references. When we reference stuff, we want to use in-text citations, and you'll see how the student's sample does that. I will allow you to reference your textbook and lab manual as well. You're welcome to do that. And then, of course, we're in high school. We should have pretty good writing skills. How many of you have taken Hatz's writing class? She's awesome, right? You should know how to write by now as juniors and seniors. I think all of you are almost seniors, right? So you'll be I'll be looking that you're doing a good job. So poor writing, right, is a way you could lose points on this. Run-on sentences, awkward wording. I'm amazed at how many of my regular bio students must not read what they write back in their head, because some of the things I get are not where I think a high school sophomore should be. So just make sure you proofread and does it make sense to you the way it's worded. Another thing that could cause you to lose points would be not having enough detail in your materials and methods. I should be able to read your materials and methods and repeat your experiment without talking to you. Should be able to redo that work. And then, like I said, I've just taken lab reports and looked at where kids are making mistakes, and I'm sharing that with you in the hopes that you won't make the same mistakes. If you have a graph, it needs to be labeled, the title, and when we get to writing these, I'll show you the best way to do that. It also needs to have units. If all you have is data, numerical data, quantitative data, and you're not telling me the units, then it's kind of meaningless. So make sure that the axes have the units labeled as well. So that's an overview of how to write a lab report, okay? What I'd like you to do right now is take some time today to read an entire lab report. Take notes on it. Jot down some things that you're seeing that you're like, oh, I wouldn't have thought to do that. That way you'll have that as a source of material to use when you're required to write your own lab report. Okay? Does anybody have any questions? We're just now starting the cardiovascular system. So tomorrow we're gonna do a POGL to get us kind of like some basic information that I can then use to connect new knowledge to. And then we'll jump into that unit, and then we'll be getting to this lab during this unit. It would help to have done some prior research before the lab, right? That way you can write your introduction, you can come up with your hypothesis, and be ready to go. What I don't want you doing is after the lab going back and trying to do things in the wrong order. So you should have a little familiarity with the topic ahead of time. So take a look at these, please, and dig through them.
Are we allowed to write on them?
No. You aren't keeping this.
Okay.
I'm gonna be collecting it back. You can look at it now, you can take notes on it, but you cannot copy it, you can't take a picture of it. Okay, because what I wanna do is avoid the tendency of students to wanna just snag stuff. It's just so hard not to do that sometimes. Oh, that sounds good, I don't know how I would write it any better, or any differently. And then all of a sudden you're writing somebody else's work. We don't want that. We want the work to be your own.
Can I go grab my notebook from my locker?
Can you grab what?
My notebook from
Yeah, of course. So again, I want you to read this, take the time to go through all of it, and then in your notebooks, you're welcome to take notes and write down anything you want. You can ask me questions about why something was done the way it was done. You're welcome. So all I've done is remove the student's name. You'll see this was done in April of 2014. It's just a really great example that I've kept over the years to show students, to really help them to write their own lab reports in a high quality manner. That's why this young lady is now a doctor. She's gone through med school, right? She went to college, did her residency, and she's done really well. And I actually have these numbered, so make sure I get them back, please. I know exactly how many are out there.